So a lot of what we did leading up to this point, 6.1, when we did Pythagorean theorem and using tangent to find our degree measure, we're just really kind of applying that in more scenarios. So really not going to see anything that is new. Just getting more used to drawing vectors and finding magnitude and direction. So I think you'll find this pretty straightforward, pretty easy. We're going to go through page 6 and 7, and then we'll start on tomorrow's task just a little bit, just to have the graph down. So we're going to start a little bit with the next task, but we'll save the rest for tomorrow. Okay. So on page 6, I don't think I want us to be having to measure using protractor and using a ruler. So I'm going to skip this top portion, and we're going to go down just to the bottom half. Okay, we'll start here. Okay, so when a grid is used, first find component form. So component form is going to help us identify the displacement, especially just the x and y values of the vector that we're going to create. Okay, so component form, we're going to practice applying that. It's just how far left or right the horizontal component is, and how in terms of vertical that we reach. So remember how yesterday we started at one point and we counted horizontally and we counted up, and we always just got to our destination by creating a right triangle. Okay, same idea here. Okay, and then we'll use theta equals inverse tangent of a over b to calculate the direction of a vector. Okay, we're going to use the calculator, but the calculator, we have to make some adjustment because depending on where they're pointing, we have to either add or subtract from 180 or subtract from 360. Okay, so we'll work through these problems, and you're going to just eventually just going to become very familiar. Okay, nothing really new. Okay, find component form, magnitude, and direction. Okay, using standard position. So we see that vector D starts at this point and ends at this point. So we're going to create, imagine that any vector that you're working with, pretend like the vector you're seeing is the hypotenuse of a right triangle, right? So we have a horizontal component, 1, 2, 3, 4, and a vertical component of 4. So your component form is going to look like this. You're going to use this this bracket. That's fine. You'll use this bracket notation, and 4 units to the right, and 4 units, 1, 2, 3, 4, 1, 2, 3. Yes, A and B. Oh, this is page 6.
Oh.
Yeah, page 6, and we'll just go down to the, we'll skip the top portion, and we're going to go down to the middle half. Bottom half. Okay. And the definition for component form is also spelled out on the very back page here. Component form shows the vector from the initial point to the terminal point based on the displacement of the dimensional value. So we're going to do horizontal and vertical. We're going to call those A and B values. Okay. So this component form is helpful because this is really the only numbers we have to see to look at to determine our magnitude and our direction. So this 4 and 3 just tells us that we can break this vector down into a horizontal component moving right 4 units and 3 up. Okay. All right, so now we want to find the magnitude. And it's just square root of a squared plus b squared. 9 plus 16 is 25, root 25 is 5, so that is our magnitude. Basically the length of this vector. And the direction, we can use inverse tangent. A over B, I'm sorry. I got the rule wrong here. It's y over x, it's b over a. So y over x or b over a, we'll say 3 over 4. Make sure you're in degree mode. Okay, use your calculator here. Inverse tangent, 3 over 4. Oops. Okay, do we need to make any adjustment to that degree measure? Yeah, it's pointing in the first quadrant, right? It's pointing in the first quadrant, so that reference angle is perfectly fine. So component form is 4, 3. This vector has a length of 5 or a magnitude of 5, and the direction is that it's pointing 36 degrees, 36.87 degrees. Okay, questions? All right, let's try number 7. Component form, we're always going to horizontal displacement followed by vertical displacement. So you're going to count from your starting point. We're going to go horizontal first and vertical. All right. So what's our A value going to be? Good, right? Left is negative and vertical down is negative. Okay, so -5. What's the vertical component? +4. There it is. That's our component form. That's very helpful because those are the only two numbers that we need to get to our magnitude and our direction. Okay. Inverse tangent. All right. Which quadrant is this pointing in? Second quadrant. So we have to make an adjustment, right? This -38 degrees is not going to be suitable for that direction. So what can we do to get to something that's in the second quadrant? Yeah, so we're going to add 180. Okay. So the nice thing is that it's already negative. So really 180 minus 38 will bring us into second quadrant. But, just always double check, right? Make sure that whatever degree measure you're looking at, it's consistent with what you know about the quadrant that it's supposed to be in. You guys get 141? Okay. So you kind of already know how to do this. We're just practicing in these types of specific problems. Okay, let's go to page 7 when you're ready. Okay, anybody still need to look at page 6? Okay. All right, so find the component form, magnitude, and direction of vector x. Vector x only has a horizontal component, right? Doesn't have a vertical component, so. So left 5 units and 0 units vertically. Okay. Magnitude. Now, if you're plugging into your calculator, make sure that you're squaring, that you're putting your negative number inside a set of parentheses before you square it. Right? Otherwise, the calculator is not going to understand that you want the negative to be part of the exponent. Okay, now we really don't have to go through this whole direction formula because we can just look at this and understand which degree is it pointing in. $180, right? You don't have to, there's no calculation really, just look at the direction, right? If it's to the right, it's 0, 90, 180. So if it's along the axis, then we can kind of just look at the graph and understand. Don't have to do any calculation. Okay, try number 2, vector u. Okay, which quadrant is vector u pointing into? Quadrant 3. So what do we have to do here? Yeah, 180 plus 180. Okay, so for 3 through 6, we're going to be creating a resultant vector out of the combinations of the provided vectors. So we're going to connect the vectors from once we finish drawing out one vector, we can start the next one where the first one left off, and then when everything is said and done, we'll just connect a vector that will go from the starting point to the ending point. Okay. Now, if you look at u, it's kind of going in a downward to the left direction, but it's going to double that, and it's going to be minus u. So minus u is going to end up going the opposite direction, right? It's going to go up. So just kind of going to give you a kind of a starting location so that you don't run out of spaces to move into. So let's start somewhere near the middle here when you build out your vector. Okay. So you'll have 2 vector u's and then followed by vector w. So if we want to go the opposite direction of W, we're going to have to make it go up 5 and to the left 5, right? It's just going to follow along the direction of W, but it's just going to go the other direction. Okay, so now your resultant vector is going to be from beginning to end. Right? This is your vector A. So all we care about is component form, magnitude, and direction for vector A. We can just basically ignore 2u minus w. We just want to focus our attention on that vector. Okay, component form. Count how many units to the left, and then count how many units vertically up. Okay, left 13 units, up 3, right? Okay, magnitude. These are the only numbers you need to look at for magnitude. Okay, which quadrant is vector A pointing into? Yeah. So after you get that number, we have to adjust it, right? Plus 180. Or 180 minus 12.995. Mm-hmm.
I have to go for a picture.
That's fine, you go. Okay, number 4. Oh, question? Yeah, go ahead. Number 4, draw a vector. Vector W plus 2V plus X. I want to let you guys start in a spot so they don't run out of room. Start here when you build your vectors. Vector W followed by 2 times vector V, 2 times vector V, and then over back to vector X. Okay, so vector B is just going to be that little portion right there, right? Okay, so you're going to answer component form, magnitude, direction just for this vector here, just for this resultant vector. Questions so far? Okay. Direction, I don't think requires any calculation. What's the direction here? 90 degrees. Let me give you a starting point for 5 and 6. Okay, start here for 5. And number 6, maybe start here. Yeah.
How do you find the direction?
Oh, the direction, usually I would do tangent, but in this case, we look at that vector B is pointing straight up. So it's just pointing at 90-degree angle. We don't have to do any calculation.
Can it have also been pointing at an angle of 270?
Not in this case, because we're starting at W and we're ending at X. So we have to start here, we have to end up here. So it's got to go up, right? Is it always going up? It depends on where the starting and ending point is. You see how we start at a lower point and we end up at a higher point. So, and it's just, yeah. Okay, questions? All right, number 5. Okay. Coniform magnitude. Are you okay with this part? All right, theta, I got negative 23.962. What adjustment do we have to make? Yeah, you see how vector C is pointing into the fourth quadrant. So we have to subtract from 360 in order to get that direction to be something that's between 270 and 360, right? We want it to be a value that's in the fourth quadrant. Okay, so let's draw a vector diagram. Any questions with 5? So start here, and then you can build your 2u minus w minus x. Oh, wait, hold on, wait a second. My bad. This is a bad place to start. My bad. I wasn't looking at the right spot. Here we go. Start here. Yeah, start on the right sides because 2u will bring you down here. Negative w will bring you up here. Negative x will bring you here, and then we can draw your resultant vector. And u is over 4 down 1 twice. Thank you. Hey, all we care about is vector D. So left and up. Okay, what adjustment do we have to make with this negative 20 degrees? Yeah, we gotta start from 180 and then subtract that or add this negative reference angle to get us something that is consistent with the second quadrant degree measure. Okay, any questions here? Okay, we're just going to start the task on page 8. All we're going to do is we're just going to follow the directions and just sketch out our vectors, and then we can continue on page 9 tomorrow. Okay. All right, Harry Potter needs to make a few stops around Hogsmeade. Harry's broom is broken, so he must walk between the buildings. Town is laid out in square blocks, which makes it easy to give directions. Here are the directions Harry must follow on Monday. Okay. So draw the route of Harry's trip on the grid below. We're going to start bottom left corner. Okay, so stop 1, destination is going to be the 3 broomsticks. We're going to go 3 blocks east and 5 blocks north. So this will be our stop 1 here. Okay, to get to stop 2, we're going to go 5 blocks east. Okay, 5 blocks east, 2 blocks north. Okay, stop 3, 2 blocks east and 1 north. All right, so how would Harry's trip change if he were to ride his broom to his 3 stops? We can just connect the points, right? So basically the hypotenuse representing each of the vectors here. So Okay, so let's see. On Tuesday, Harry has more errands to run. When he is done, he will meet Ron at the Shrieking Shack, found 3 blocks west and 3 blocks west and 3 blocks north of Hogwarts. So we know where it's going to end up here. It's going to end up 3 blocks west, so 3 blocks north. 1, 2, 3. Okay, so this is the final destination. Okay. All right, so stop 1. We're going to go 2 blocks east, 4 blocks north. Four to the left and 3. Okay, so again, we're going to connect them like as if he were able to travel even more efficiently. Okay, next stop, 5 blocks west, or you can think of it as negative 5 blocks east, 5 blocks south, 3 blocks south, which is negative 3 blocks north. Okay, so we're going to go 5 to the left and 3 down. So then from stop 3 to stop 4, we got to figure out what will it take to get to that final destination, right? So we're going to go 1, 2, 4 blocks east. And then 1 block south. Okay. All right, we'll pick this up tomorrow. Let me just check your pages 6 through 8. Yeah.
Oh, that's after I say. Oh, no, what? Yeah, that's right. Oh, I can't write it. Oh, okay. Then make pictures. I don't know. Yeah, I think that's what I'm gonna do. It's like, I need the whole time. And like, he even told me, like, it's like, your other work's good, but you can't afford to do things just after you get your own. And like,
This way. Can I look this way?
Go ahead.
so I'm like, I'm not worried about it. But like, you have a research. She's really nice.
Mr. Yang, when did we get out again?
What?
Oh, yeah, let me put the,
I don't remember them crying. I mean, she's not like more patriotic than most. I don't think so. I mean,
It's just like that. I have no idea. I
It was
don't
probably,
know.
I don't know. She doesn't do, I don't remember. She just says it. But I don't think it's
Oh, yeah, one of the good friends died.
Yeah, I was gonna say, cause like, I mean, she's not like.
Yeah, it's just what I heard.
Yeah. I mean, she really likes filmmaking. Because there
Oh,
was like an
no,
essay
yeah.
question. There's one essay question that was about like filmmakers and like other like students clubs. She's nice. I think she was.
You guys ready for it? You know, if we have to do that.
I hate pistol Brian.
Did you what?
She hates my guts for no reason.
You got it.
Back in class.
Are you serious?
First.
Like she was like really, I don't know, maybe like.
Like, we were supposed to have a time
It's not
for
like-
it. Let us do it.
Yeah, I don't know, maybe like it was not very certain. I don't think.
Just add some value. You got such a bias on my first grade. It is so annoying. It's like
You got caught on that. So how are you gonna get that? Like, really? I just shared it in my what do you expect?
It's okay. Yeah. I don't need to be in here.
Like, probably just Googling stuff. And I mean, her tests were hard, don't get me wrong, like her assignments were kind of hard. But
They're not as bad as not doing.
I don't know, the AP questions on the AP questions are hard. Those are always hard. Like they're harder than the supplementary questions. You're bound to be like, if you get a 70, that's a good grade.
Yeah. It's weird, cause like I could probably argue 2 or 3 answers. So it's
Yeah,
kind of hard to figure out what it is.
yeah, but that's not really any.
No.
They're just as hard as questions. I would work it.
Oh, I saw that one. Did you post that on your story?
I think I did, yeah.
How did it?
Oh, I was like. It's the man.
Oh, I forgot about that.
Yeah, so did I. That's why when I came across it, I was like, wait, this looks familiar, but I completely forgot. I was talking about it and I like, I know, but I like look at my face shininess. I'm pretty just not good enough. Just looking at it, like it's just so funny. I don't know why. But it looks like the kind of thing I would be good at and makes me do this and pressure.
How about you want to bet that's not actually? Okay, so I was talking with Carolyn, because we're in the same psych class. You know that whole thing M&M post Keely said?
Yeah.
We were going through their account.
Oh, no. I'm finding it. I